Okay, we're going to be doing decimals this week, and so we've got to first find out what decimals means. Decimal. Deci is for 10. Everything goes by power of 10. Now you guys are used to numbers like 2,384. You'll notice this 8, because of where it is not an 8. You guys have learned these positions. There's the ones position, there's the tens, there's the hundreds. There's the thousands. So really this 2 doesn't represent 2, it represents 2 thousands because it's that big. Now, we're going to first talk about how to add them, then we're going to subtract them, then we're going to multiply them, then we're going to divide them. Now in adding decimals, breaking them up is actually the most important thing to do. The representation of this as 2 thousands plus 3 hundreds plus 8 tens plus 4 ones may seem quite tedious, but it actually becomes one of the most important things in addition. When we take this right here and we try to add this number to, say, 483, this is 4 hundreds plus 8 tens plus 3 ones. Now, when we add them, somebody might give you the problem that looks like this. 2,384 plus 483. And in the current math experience that you have, you're thinking, you know what? That's all right. That's all right. No, you wouldn't say that at all. You're like, no, of course not. You got to have the 3 underneath the 4. Have you ever thought about why? Why do you need the 3 under the 4? We're going to break for that just a minute. I'm going to ask you a couple of questions. You have 5 apples plus 3 apples. You get what? Obviously, you got 8 apples going on. Okay? You have 5 penguins plus 3 penguins. You have 8 penguins. Now, the real question. What if I have 5 apples and 3 sheep? 5 apples plus 3 sheep is 8 what? We don't know. You have 5 apples and 3 sheep. You can't add things that aren't alike. So right over here, this 3 represent ones. This 8 represents how many tens you have. So when you take this 3 up here that represents how many hundreds, you're saying 3 hundreds plus 8 tens, and it doesn't work at all. That's the whole idea when you are adding decimals, that you have to line up the decimals. So when you take this and write it out, so you have a 4, 8, and a 3 right there. Now you've got 4 ones and 3 ones, that's 7 ones. 8 tens and 8 tens, that gives you 16 tens. You guys are well aware of being able to carry that 1. And then you have 4 plus 3 plus 1. This gives you how many hundreds? So that's why you have 7 hundreds and then 2 thousands. Let's try another one. Two 238.4 plus 7.28. Something like that. Now again, it just looks odd. You're like, that's not quite right. And that's correct. Here, this 2 represents hundreds, that 7 represents ones. You got 2 hundreds plus 7 ones. It's like adding apples and sheep. You can't do it. That's why that decimal point needs to be exactly lined up. You then write it out, 238.4 plus 7.28. The decimal point lining up, make sure that you're putting tenths with tenths, ones with ones, hundreds and hundreds. So you have 8 because you have 0 hundredths here, plus 8 hundredths. 4 tenths plus 2 tenths is 6 tenths. 8 and 7, that's 15. Again, that's 5 ones and 1 10. That's a 4, and then we have 2, so 245.68. Let's write that up right now. You have to add like things. And then you get to carry by tens. As soon as you have 10 of something, it goes over to the next column. And actually, that's why we're dealing with decimals. When we deal with fractions in a little bit next week, we're going to be able to deal with things that are not in tens. Subtraction, same thing. You got to do with like things, but this time instead of carrying, you're going to borrow. Let's make sure we've got that idea. With subtraction, we want to make sure you understand that it's more like cashing in. Like when you're borrowing and carrying, you're exchanging some things. So I'm going to put up here some money. $258.36 plus 4.38. Let's not do that. 258.36 minus 4.38. Now again, we have to have those decimals lined up exactly where they need to go. So let's put that where it should go. Now, here's where we get to the borrowing idea. Here we have 6 pennies. We got to try to take away 8 of those. We can't really do that too well, because if you only have 6, you can't really take away more than 6 of them. So here's where we get the idea that if we take one of these, dimes, for example, so we cut it down to 2, and take those 10 and cash it in for 10 pennies. Then we have that right there. 16 of them now, minus 8 gives us 8. Then we run into a problem here. 2 minus 3. You can't really do that. It doesn't go down below 0 very well. So you have, take one of those and it'll give you 10 of those. And that's where you get the 9, 3, 5, 2. There we go. That'll give you the basics of subtraction. So here we're going to borrow. This together, when you are carrying and borrowing, officially the name is regrouping. With subtraction, one thing we need to make sure we understand is the negative sign. Now, we've talked a little bit about it, but that little dash has caused a lot of people a lot of problems in math for many years. So I need to tell you exactly where it came from. There's a little bit of a history of numbers that goes into this. When people first invented numbers, they invented them as adjectives. They used them to describe things in nature. For example, when I came to work today, I saw trees. You have an idea of what I saw. Somewhere in your brain you have this mental picture. But it might not be exactly what I was trying to describe. So I add adjectives to that. And so I add small. I saw small trees on my way to work. And that might adjust a little bit of what you are imagining now. So I saw small yellow trees. Again, another adjective gives you more definition of what I saw. So they invented numbers so that I would not have to go out and show you exactly how many trees I have. So, small, yellow, 5. 5 small yellow trees. And it gives you a clear picture of what it was. So they called all these numbers that you could describe things in nature as natural numbers. Well, they had a debate on whether or not 0 was a number. As you can imagine, if you're describing what's in nature, and you said, oh, hey, look, I've got a number of elephants standing right next to this board. No, you don't. You don't have any. They're like, exactly, 0. It describes what's not there. Well, that's what's so unique about the number 0, is you're using it to describe what is absent, what's not there. So there's this debate on whether or not 0 should be a number, and finally the mathematicians caved in and said, okay, 0 can be like a real number. That's great, fine. We now can describe everything that's there and everything that's not there. Well, then someone came up with the idea. They said, aha, we're going to take the number 5 and we're going to subtract 8. 5 minus 8. Well, the traditionalist thinkers thought, how can you do that? If you have 5 trees and you then take away 8 of them, you're like, that doesn't make any sense. Now, many of you are familiar with the number line, which is a great way to think about this. You've got the number 5. And you're going to go this way, 1, 2, 3, 4, 5, and then you're going to keep going. That's a great way to think about it. The positives are up there, the negatives are down there. But have you ever thought that -3 there, you're like, what do you mean -3? If I were to tell you, on my way to work, I saw -3 small yellow trees, you might think me a bit odd. Have you ever considered what a rope would look like that is -10 feet long? Or negatives just don't make sense in that regard. So, what does this negative actually mean? And that's what you need to understand. That this negative was created to mean other direction. So if you consider money and you have $5 or anything, this -8 is saying you are now going in debt or losing $8. And so this means you can't necessarily have -$3 in a bank account. That would be very difficult to open up the bank account and count it out, -1, -2, -3. It doesn't make sense. This just means that $3 is now in debt. When altitude, you have sea level is kind of 0. You can have 5 feet above sea level and 5 feet below sea level, and that makes sense. Well, the negative just tells you which direction the 5 feet is going. So this is what we're going to do with this other sign. So when we do subtraction, and we have things like -7 minus 3. Like, oh boy, what's going on with that? Well, here we have 7 going in the opposite direction. And then we're going to subtract, that way, 3. So we're down here at a -10. Whenever I have minus signs, I like to kind of think of them as tug-of-war. When you have a positive and negative, they're pulling against each other. And the stronger one is going to win. And when you have 2 negatives, as here we have a -7 minus 3. It's like having a -3 on it. They're pulling in the same direction, so this is going to pull it all the way down to the -10 right down there. Consider this with a couple of English terms to it, a couple of descriptions in words. If this means, say, debt, when you're talking about money, here you have a debt of $7, and here you are going into debt another $3. Your total debt would be 10. Makes sense like that. Another way of thinking about it is with temperature. If it is currently -7 degrees cold out there, this means it's getting colder by 3 degrees, so you're going to be down at -10. All three of those are really good ways to think about it. Number line, where you're visually, subtraction means that way, plus means you're going that way. Let's do a couple more. -18 plus 5. Now in this case, you see a -18 and a +5. They're tug-of-warring against each other. So the -18 is going to win. This one's bigger. So -18 degrees, and then it gets warmer by 5. You're up at a -13. If you had a -5 plus 18, you have the same thing going on, that these two are tug-of-warring against each other. So you're kind of subtracting them to see who wins by how much. And this time you're going to be at a +13. Let's try one more. -7 minus a -10. Now this is where this negative sign, meaning other direction, is most key. Right here we're taking -7 and we're subtracting a 10, but it going in the opposite direction. So these two going in the opposite direction means we are now going positive. If you think about it in money, we have $7 in debt, and we just lost a debt of $10. That means we just gained $10. That's where the negative goes. So that becomes a +3. Now, this little nifty contraption here is kind of nice. That you have that the 5 with the -18 is exactly opposite of a -5 with a +18. That's going to help you when you have tough problems such as this one. 25.68 minus 384.12. We have a major problem here. 25.68 minus 384.12. How do you do that kind of a problem? you've only got 25 and you're taking away 384. Well, you're going to end up negative, so that's the idea. Now we're going to use this key over here, and if you were to subtract these backwards, take the 384.12 and subtract that, you'll get exactly the opposite answer, just like with this. Here you had a 5 and a minus 18, gave you a negative 13. Negative 5 and a positive 18 gave you 13. So if I do this problem, 384.12, and I subtract the 25.68, this answer is going to be positive, but it will be the same number just in the other direction from this one. So what I'm going to do is, most often you've seen the subtract sign here, I'm going to put it up here just to remind me that this guy is stronger and he's going to win, but still do a subtraction. We're going to borrow like normal. 12 minus 8 is 4. 10 minus 6 is 4. 13 minus 5 is 8. 7 minus 2 is 5. And then 3 comes down here like that. And this guy was stronger, so he won. Negative 358.44. So that takes care of subtraction with decimals. Let's make sure we can do that. We'll do one more of those. So again, we have a problem here, 584.36 minus 843.9, and we're going to take it and put the strongest one up on top so we can subtract it like normal. And just remember that this guy is really stronger. We're going to write it up here, negative 843.9 and a positive 584.36. And we're going to subtract them. Right here, this becomes really difficult. We don't have any hundredths, and we're subtracting 6 hundredths. So we better put the 0 here so that we can properly borrow. So we cashed in one of those and got 10 on the other side. 10 minus 6 is 4. 8 minus 3 is 5. Oop, 3 minus 4, not happening so well. 13 minus 4 is 9. 13 minus 8 is 5. And 7 minus 5 is 2. And this guy is the stronger one and wins, so we end up at a negative 259.54. So that kind of takes care of subtraction and what you get with this negative sign. Now, we move on to the multiplication. I'm going to leave this negative sign up here because we deal with negatives when we multiply as well. So a little time sign here. Now, many of you remember doing this. We're kind of reviewing right now, but you take 5 times 8 and you get 40 and you carry that 4 up there. Now, if you ever wondered why that is, 5 times 8 is 40. That's 4 10s and 0 ones. So we put the 0 in the ones place and the 4 in the tens place. So now when we have 5 times 3, that's 15 tens because the 3 is in the tens place. 3 tens plus 4 more tens that we carried over from there. That's where we get that carrying going on. So you get 15 plus 4 is 19. So we have 19 tens, which is 9 tens and 100. So 5 times 2 is 10, plus 1 is 11. Now, you should note that when we're going to times this 4 through the whole thing, this is not a 4. Never was a 4. That 4 is in the tens place, which means that is 40, not 4. So, because this is a 40, we've got to have an extra 0 there. Now we can do 4 times 8 is 32. 4 times 3 is 12, plus 3 is 15. 4 times 2 is 8, plus 1 is 9. And we add those together. So this guy right here was 5 times 238. And this guy right here was 40 times 238. And so when we add them, we get 45 times 238. So we get 10,000 710. Now, this negative sign still means other direction. It always has. That's what it does. So if either one of these were negative, such as negative 238 times 45, we have 238 times 45 in the opposite direction becomes a negative. If they were both negative, negative 238 times a negative 45, we're taking 238 times 45 in the opposite direction, in the opposite direction. Think about what happens on the number line. If we have a number up here, like 10,710, that going in the opposite direction is down here. Now if we take that and make it go in the opposite direction, we're now, and this is where the line comes from, if you've ever heard it, two negatives make a positive. That's what's going on right there, is that you're taking this positive number, moving in the opposite direction to get a negative, moving in the opposite direction to get a, and it'll move it right back to the positive side. Okay, so that was multiplication. Multiplication involving decimals or zeros is kind of handy. Let's do one more. 385.6 times 4.2. So we're going to do the exact same thing. 2 times 6 is 12 with a little 1. 10 plus 1 is 11. 2 times 8 is 16 plus 1 is 17. And 2 times 3 is 6 plus 1 is 7. Let's not get mixed up as we times the 4 through. So now we're going to go 4 going through those whole things. So 4 times 6. Oh, we got to make sure this is 0 because this guy is 10 times bigger than that one. So it can't line up exactly the same. 4 times 6 is 4. 2, 4 times 5 is 20. Plus 2 is a 22. 4 times 8 is 32. Plus 2 is 34. 4 times 3 is 12. Plus 3 is a 15. Then we add them up and we get 2, 5, 9, 11, 6, 1. Now here we have the number 161952. Notice that this guy right here is a tenth. And that guy right there is a tenth. When you take a tenth times a tenth, you're going to get a hundredth. So this guy right here better be in the hundredths position. So here comes the shortcut. The total number of decimal places up here, 1, 2, is going to be where you put the decimal down here. So we have 2 decimal places. In this case, it's 1619.52. Your little work on estimation is actually going to help you out here. Here we have roughly 400. Here we have 4. 400 times 4, 1600. Our answer better be somewhere around 1600 right here. If you've forgotten the rules on decimals and say, ooh, yeah, 1, 1, 1. Notice that this thing is not near 1600. It's about 16,000. The estimation gives you a good idea and says, that's where the decimal would need to be anyway. So we're right around 1600. Let's do one more of those examples. Seven times 6 is 42. 7 times 5 is 35. Plus 4 is a 39. And then we're just going to have zeros the rest of the way. So now take 2 going into 6. Make sure this is 10 times bigger than that, so we've got to have a 0. If there were 3 numbers, we'd have 2 zeros on the next level. So 2 times 6 is 2, 1, 12. 2 times 5 is 10, plus 1 is 11. We're going to have zeros back there. So now we add it. 2 plus 0 is 2. 9 plus 2 is 11. And 4, 5, and a 1. So we look at this, and now to get the decimal in the right spot, we now have 1, 2, 3, 4, 5, 6 decimal places behind the decimal. So the decimal can't be here. That'll only give us one spot. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is where our decimal now is. And that's the end result. Okay, so there we have multiplication of decimals. The final review that we're going to do is the division of decimals. Make sure you guys are able to do that and being able to change things into percents. So, better write that down. Dividing things into decimals. So if we had something like 238.4 divided by 0.7. Now, I don't know about you, but I don't remember my 0.7 times tables really, really well. You don't just have it running around in your head, oh, 0.7 times 13 is this, and 0.7 times 18 is that, whatever. We don't know it very well. So this isn't really comfortable and say, okay, 0.7 goes into 2 how many times? You're like, I don't know. The big secret here is that this division sign, funny that, and this division sign, when you put a number up here where that dot is, you put a number down there where that dot is, this fraction is exactly the same thing. Now, we're going to cover fractions in greater depth in just a little while, but one thing I want to review with fractions is that you can times anything on the top and the bottom and have it work, have it be the exact same thing. So if I times by 10 and times by 10, I now have 2, 3, 8, 4 on the top and 7 on the bottom, which means that this is the exact same thing as 2, 3, 8, 4 divided by 7. This then becomes the problem that you're able to do. 7 goes into 23. Aha, goes in 3 times. 3 times 7 is 21, and we subtract. 7 goes into 28 4 times. Subtract, and we get a 0. Then we drop down the 4. 7 goes into 4 0 times. Now this is where you get to change this. Instead of just saying, oh, we must have a remainder 4, put a decimal there and say, hey, let's keep going. Let's see what happens. 7 goes into, drop that one down, 40. 7 goes into 40 5 times. 5 times 7 is 35. And then you subtract. 7 goes into 50 7 times. 49. And it keeps going like that. The answers on your assignment will sometimes be rounded out at 2 decimal places or 3 decimal places. So as soon as you get an idea out there a few, go ahead and stop for a minute. All right, let's do one more problem like that. .687 divided by 0.6. I'm going to write it out like that. 0.6, 3687. And again, we're going to move the decimal. We're really timesing top and bottom of a fraction by 10 when we do this. So we get 6 into 3687, and the decimal is now right there. So 6 goes into 36 6 times. Multiply it down. Drop down the 8. 6 goes into 8 1 time. So we have 1 times 6 is 6. 2. And drop down the 7. 6 goes into 27 4 times. 7 minus 4 is 3. And again, we can just add as many zeros as we want to. 6 goes into 30 5 times. And it came out nice right there. So 6.145 is the answer. Now, one of the things that division of decimals will let us do is you can actually take a fraction, any fraction out there, and turn it into a decimal. You guys have seen this a lot when you get answers on quizzes, get scores, grades in school. You have something where you're like, okay, so I got 4 out of 5 on a quiz. And you're like, what percent is that? And again, this is a divide sign, so that's exactly what we're going to do. We're going to take 4 and divide it by 5. You notice 5 doesn't go into 4. But if you put these zeros here, you can find out exactly what decimal it is. So 5 goes into 4D 8 times. Excellent. We now have 0.8. So we're able to convert the fraction into the decimal. Let's do that on one more fraction. Make sure we're okay with that. We're going to say you got 7 out of 9. This one is going to go 9, goes into 7, a couple of decimals. Let's see what it works. 9 goes into 7. Nope. 9 goes into 70. 7 times. 7 times 9 is 63. Subtract and you get a 7. Drop it down. You're like, okay, 9 goes into 70. 7 times. 7 times 9 is 63. Subtract and you get a 7. Drop down the 0. 9 goes into 70. And about this time you're like, wait a minute. This sounds familiar. I think I did this before. You're starting to establish a pattern where the 7 is going to keep going forever. The symbol to represent that is a bar over the 7 like that. So 7/9 is 0.7777 repeater. If you want to, you can write it with the bar over it. That's extremely accurate. Most people write 0.778, and they'll round at some point, rounding appropriately and moving it up. Now, if you got a quiz score, 4 out of 5, we want to change everything into a percent. Now I wrote that with a little break between per and cent because per means divided by or, per. And then you have cent, which is 100. Or in other words, how many hundredths? In this guy, this is 0.8. That's 8 tenths. If you fill it out all the way to here, it's an 80%. And that kind of makes sense. You get 4 out of 5, you got an 80% going on. 80%, however, you'll notice the difference between this and this is when you move the decimal 2 places. So this one, changing over to a percent, would be 77.8%. Equally well, you could have written it as 77.7 with a bar over it, percent. Let's do one more and make sure you're okay with changing these into percents. 5 out of 7. We're going to take 5, divide it by 7. 7 goes into 5. Nope, 7 goes into 50. 7 times. It's 49. Subtract, and we get 1, 0. 7 goes into 10 once. 3, 0. So 7 goes into 30 4 times. It's 28. Subtract, and you get a 2. We'll do one more. 7 goes into 23 times. So it's going to keep going. It may go on forever. In fact, fractions do. They go on forever in some sort of a pattern. So, just kidding, that's not a 3, that's a 2. 2 times 7 would be 14, and so on. So right here, 0.714, if we move the decimal 2 places, we could write it as 71.4%. That 2 tells us that it'll round down to a 4. Now, the interesting thing about percents, while we're on percents, we need to talk a little bit about percents. Okay, percents never tell you exactly the amount that is happening. They tell you a portion, but they don't tell you a real amount. So, we need to talk a little bit about that. The easiest thing for you to understand, and the easiest one for students at BYU Idaho, is tithing. if you consider how much you pay in tithing, it is universal throughout the church that tithing is 10%. But if you consider how much you pay and how much your neighbor might be paying and how much your priesthood leader might be paying and the Relief Society president might be paying, they all might be different amounts. So we have that. If someone makes $250, the tithing on this, the 10%, is going to be $25. If you have $850, the tithing here, 10%, is going to be $85. And so you'll notice that even though the percents are exactly the same, you always need to know what the percent is of. And this is a huge thing. Right here we did 10% of 850. Here this is 10% of 250. So anytime a percent is given to you, it's not sufficient in and of itself. It doesn't tell you an amount. But what it does tell you is the portion of something, and that's what's crucial about that. So on percents, you're going to take, if we gave you something like 20% of 318, we're going to take 20%, which is 0.20. That's how you change a percent into a decimal. You're going to move the decimal back 2 places. So 0.2 of, this means times, and you have 318. Let's do it up here. 318 times 0.2. 2 times 8 is 6. 1, 2 times 1 is 2. Plus the 1 is 3. 2 times 3 is 6. We have 1 decimal place. So 20% of 318 is 63.6. Let's try one more of this. Whew. Okay, let's do one more. 13% of 4,281. We're going to take 4,281 times 13%, which is listed as a number as 0.13. That's 13%. So we have 3 times 1 is 3. 3 times 8 is 24. 3 times 2 is 6. Plus the 2 is 8. 3 times 4 is 12. And we have 1. That's kind of nice. 1 times everything here. You get a 4, 2, 8, 1. Then we have 3, 5, 16, 5, 5. Now the decimal place goes where? We got 1, 2 total decimal places. So this is going to end up in the decimals place. So 13% of 4,281 is 556.53.